Now that we have already made the schematic of the XOR gate, we will move on to making the layout. But for making the layout, we need the stick diagram. Here is a stick diagram that I have drawn. This says that my A terminal, one terminal is connected to VDD, other is connected to B bar, one terminal of B bar is connected to output. I drew this stick diagram and we will draw the layout according to this stick diagram. So let's start. First we have to make a new cell, select layout, and the name has to be same as the earlier one, so we'll say XOR. Okay. I guess I made the schematic in the wrong cell. I made the layout in inverter. Now I'll just do Control Z. To avoid this error, what can we do is check the library. The library was inverter. I had to select XOR gate. So XOR and say OK. Yes. Now the layout has been created. Now as per my schematic and my stick diagram, what do I need? I need 1, 2, 3, 4. I need 4 PMOS and I need 4 NMOS. So let's first put them together. Select a PMOS, place it, rotate it, select an NMOS, place it, rotate it, change the width also, properties, width is 10, change the width of the NMOS also to 10, set the spice model. Now what I did here is I have set a shortcut. Tools, simulation spice, set spice model. My shortcut is W, so I press W to set the spice model. Now control and click till, press control and click until the X mark appears, and then edit the properties to PMOS and here to NMOS. Now I will copy the PMOS and paste. Click, Control V, click, then click again, Control V, click again. Yes. Now click on the NMOS, Control C, click somewhere else, then Control V. Again click somewhere, Control V, click somewhere, Control V. I have my 4 PMOS and NMOS ready. Now let's take a look at the contacts. I need 1, 2 and 3 contacts. The X mark denotes contacts, so I need 3 contacts for PMOS and 1, 2, 3, 4, 5 contacts for NMOS. So let's place them. For PMOS I need P active region, so I'll place 1. P active region I need 2 here and the third one here. For N active region I need 5, so there will be 1, 2, 3, 4 and 5. So 1 here, 1 here, click, and one here. Now I want to change the width of all of them to 10. So what will I do? I will click on one. I'll press shift and click again. My shift is pressed and I'll click again. When you press shift and click, it is like you are selecting multiple objects at a time. So I've selected all of them and then I'll open properties. Now I'll change the Y size to 10. Yes. Now let's make the connections. But before making the layout, let's make the connections first, then we will move further. Left click, right click, left, right. Make sure that they are well aligned. Okay, now let's move the PMOS. You know the error is seen, but you can just ignore that. Now move this one. And this. Basically get them all together. Similarly for the NMOS transistors. Okay, so let me just select all of them and bring them a little more down for safety so that no region overlaps. Now fill window, left click, right click, and then right click, left click, right click, and right click, left click, right click, right click. We can just move this entire thing little so that you can find it in one line. Okay, somewhat similar. Yes, now let us check for DRC errors. No DRC errors as of now. Okay, so we are done with this. Now what do we need? We need to make these connections, right? So we need a VDD line and a ground line. So for VDD I will use the N well, and for ground the P well. Okay, make the X size, I say it will be 50. We might require more. As of now, let's keep 50. Fine. Now before making connections, what happened in this schematic is we have used two inverters. So we will need two inverters in this too. So for that we will just click on this PMOS, Control C, Control V. So I have my PMOS here. One inverter. I am making two inverters, one here and one over here. NMOS. Okay, first let's make the inverters and then we will adjust. And also we need inactive regions, Control C, Control V. Copy the P active region for the contacts. Now connect them. Connection from diffusion to the contact. Get them close. Okay, now since we need all the PMOS in one line, I will just move this such that it seems to be one region, the dotted line, just touching. Now the NMOS will be exactly below it, exactly below the gate of the PMOS. And for this NMOS too. Okay, let's connect the gates. Fine. Yeah, we'll just move this a bit more. Okay, now we are done. Let's check for DRC. Oh, we have 4 errors. And what are they? They say they are not touching. We have to move them much more closer. Okay. Yes. While selecting, if the straight line here is being affected, then just delete the gate that you've drawn and then move. Let's check now. Okay, we have no errors. Fine. Now I need a VDD connection here and here too, so I will have to extend this. Say I need to double it somewhat. Let me see if 100 will do. It is not done. Let me make it 110. Yeah, enough. Similarly for this. Yes, we'll just adjust it. Okay, save your design, and now again go for DRC checks. No errors yet. Now let us just make the inverter. This is one inverter. Here we've done with the inverters. One of my input will be from here. Suppose my A is this one. So okay, let me check this. Can you see this dark line here, which means while connecting I just made an extra connection or something. Let me delete this. Can you see this blue? Yes, this shouldn't be here. Just left click, right click. See, so you can just click on this and delete this. Check for DRC errors at every step so that you don't have any errors further. Okay, this means that there is no connection. Maybe they are not aligned. Now they are in one line. Yes, now it is proper. Done. Now let us connect as per our schematic. Okay, so just a reminder, this is our inverter, these two, and this is the XOR. So now the the stick diagram which I have drawn is for this particular region. Okay, now as you can see, terminal of A, suppose this is my A, so it is connected to VDD, and last of B is connected to VDD. So what do I have? If this is my A, this is connected to VDD, and if this is my B, this is connected to VDD, and this is connected to the output. Let me first see. The other terminal of B for NMOS is connected to ground, so I will make that connection, and one terminal of A connected to the contact between B bar and A bar. So let's make it. This left click, right click. Don't right click on the PMOS, on the polysilicon, otherwise a contact will be formed. Make sure that the polysilicon is not connected, I mean not highlighted. Okay, we're done. This is the output, the ground. We can just shift this down, and what we will do is, no, let this be up here. We will move this up so that they don't overlap exactly. Yeah, looks fine. Take care of the spacing that it says. Okay, let's check for errors. Now we need to connect this, and this. We need to connect all this to each other, but I can't use a metal one again, so I will have to use a metal 2. So I will, since this contact is from metal 1 to metal 2, I will place 3 of them. one here, second one over here, third is here. Okay, now make the connection. These connections will be metal 1 connections. That is fine enough. Okay, now I want a metal 2 going up, but if I just connect the 2, metal 1 might come again, which will give me an error. So just click on the pink wire here. This denotes metal 3. So, and left click, right click. Now we get metal 3 and right click again. So now metal 3 is passed. Let's check for DRC errors. 3 of them. Okay, the contact and the blue wire is too close to each other. Let's try moving the contact a bit down. Yes, possible. So we will move the entire metal 2 down. You can just delete this extra part. Yeah. Yeah, don't do this. What happens? The contact is created on the diffusion, whereas we want the contact here. Yes. You can just place the contact and then connect the two. No errors. Okay. Till here we are done, but just a piece of advice, like how I check for DRC errors after every 2 or 3 connections that I make. You also check for DRC errors every now and then, because if you just accumulate them, they will go on to 20, 25 and I don't know what all number. But then just try to minimize the errors at every step. So this is done. Now we need our connections, right? A bar, B bar. Now let us see once again. Okay, this is our A and this is our B. Let me first make those connections. I say this is my A. So since this is my A, I will connect it like this. Poly to poly connection. This is my B. So connected here. DRC, no errors. You might get an error that the spacing is not good enough. No. Okay. Fine. So to give my terminal, give my input A, I will use these two. You know how to connect these, right? Yes. Left click, right click somewhere between, and then right click again. So this is my A, this is my B, and I gave my B here and my A here. Now I want to connect my output, so let me check. This is my B bar besides A, and A bar is besides B. So what can we do? Since this is my A bar, I need to make the connection here. I will take the poly up and say here. Okay, then and right click. Try to make maximum use of metal 1 and not use of poly. I get two contacts somehow. Yeah, this is good, but this might give an error. I can't bring this down either, so I will just have the contact here. I want the contact down. This won't do. So I'll get this down. Fine enough. Now I need to check for errors because these two regions are too close to each other. Yes, I have errors. And okay, they are of this metal being very close to this contact, so I can just shift this up. Done. Now I need to connect this to my output, so I'll just change my connections a bit. Instead of connecting from down, I will connect this from up. It's one and the same, right? Okay, done with this. Now I want to connect this to the output. So again, 1, 2. Now I doubt if a contact will fit here. It will give an error, so I will fit the contact here. I'm using the wrong contact. I should use the poly to metal 1 contact. Okay, now metal 1 connection and the poly connection. I don't want a thick poly, so I will just double click on the arc and change the width to 2. Okay, now let me just adjust the poly so that it is well spaced. I have 3 errors. Okay, it says that this poly and these gates are too close to each other. We will shift this down. Tools. Yeah, our layout is complete. Now let us export the terminal. Control E, and this is my A. Control E, this is my B. Control E, this is my VDD. Control E, my ground. And I should have one output, right? So what will I do? I'll just move this down. And I'll place my output terminal first here, and I just want to connect this. And okay, check for spacing, no errors. Now what I intend to do is, even if I have it placed here, Control Z, instead of placing it there, let me just place it here and connect my output to this terminal. Okay, now I'll move this inside. I guess the spacing is fine enough, but let me just check. Okay, now what am I trying to do here is, if I intend to use this XOR gate layout in, suppose, my half adder or full adder, So I will need to take the output from here to outside, and then it should not give me any errors. So I just drew one temporary line, and let me check if I get any errors. Okay, no, I don't get any errors, so which means my output is safe and it can be here. Just that I can't take the output from here because there is a contact here. If I try to do that, it might give me errors. Let's check. See, like this, and as you can see, it overlaps with my B terminal, which I don't want. And if I go for DRCs, yes, I get errors like the contacts are too close and all. So whenever you will use this particular layout, let me just export this out. Whenever you will use this particular layout in your half adder or full adder, remember that the out terminal will come out from here, and then you will connect, and not on the right side, it will come out on the left side. Just make sure, because if you take the out terminal out from here, it will give you errors. Okay, since let's check once more. So till now this is fine. Let's check for ERC errors. No ERC errors. Let's check for NCC. Yes, we have few NCC errors. Now what are they? We have equal number of paths, wires and ports. PMOS stack at 3. There is some connection which is not correct. Let us verify it with our stick diagram. Let's see. One terminal connected to VDD, not A. This is A. Yes. This is out. Okay. This terminal is A bar. B bar is connected here, correct. And this is done. This seems correct. Let's check again what is the NCC error. PMOS 2 stack at PMOS 3. Okay. PMOS 2. Which is my PMOS 2? It's my PMOS 0. PMOS 1. PMOS 2. And this is my sorry, this was my contact. This is my PMOS 3. Sorry, NCC. PMOS at 3 and PMOS at 3. It seems correct. Let us check the layout. I guess this is PMOS at 3, right? Yes. It says PMOS at 3 should be connected to the output terminal, and PMOS at 2 is connected to VDD. So, which means these two, according to them, should be interchanged. So we can do one thing here. Let's try doing this. Delete this wire and this wire. Make connection here. It's one and the same, right? Okay. Don't forget there was no connection here. The blue dot did not denote this. Let's check any DRC errors. One error. And arced angles. Let me just delete that R. Now, no errors. Let me go to the layout, DRC check, ERC, NCC. Yes, it's completed. So instead of making changes in the layout like shifting this here, what I did is I just changed the sequence here because they both are in series. Pause, stop, cut. Right, so let's check if our layout is working, for which what will I do, I will just copy this code, Control C, and paste it in the layout. I want to paste it down here. Yes, now let me once last time check for all errors. Yes, it's all done. Now let's simulate. Okay, VA out. So now V out and VA. Yes, for 1 1 we have 0, 0 1 is 1. The transition there is a glitch. For 1 0 it is 1, and for 0 0 it is 0. Correct. This makes our layout ready.